So my name is Jonathan Racinos, and I help organize these meetups from the Konveyor side. And I just want to give a big thank you to Jaya Bhaskaran for helping us to organize this. So today we have Marco Berube, who will be presenting on the open source tool called Crane, and he will also be giving you a little bit deeper details into the Konveyor community. And before he does that, I'll actually give you a little bit more context about the community itself. So Konveyor is really an open source community built or powered by Red Hat, and we're building the community around being able to build tools that help you migrate to Kubernetes, and you can think of that as the first pillar. And then the second pillar is really having these weekly meetups where what we do is we try to have practitioners come on and share their best practices. We have other people who have open source tools that also allow you to migrate Kubernetes. We have them present their demos or their tools, or sometimes it's just tools where they will help you be successful once you're on Kubernetes. And aside from that, that's really the high level stuff that I think you need to know going into this. Marco dive deeper into all of it. And if you're interested in getting updates on the tools or the meetups, or you want to speak at the meetup, you can contact me. And I'll also put a link in the chat where you can go to it and make sure you get these updates. So with that, Marco, it's all yours.
Thanks, Jonathan. Let me screen. Guys, give me 1 second. Hopefully this is working. Jonathan, can you?
Yep, I can see it.
Perfect, thank you. Yeah, so my name is Marco Berube. I'm a product manager working at Red Hat on migration tools. So the tool we're going to talk about today mostly is called Crane. So Crane is one of the projects in the open source community called Konveyor. But Konveyor includes multiple projects or migration tools, as Jonathan pointed out, and the relationship between all those tools is that helping our customers to actually migrate their applications or modernize their applications on top of Kubernetes. And from some of those tools as well, from a Red Hat perspective, also a few times a year, we release those tools as fully supported downstream tools as well under Red Hat, which becomes either the migration toolkit for application, containers, or virtualization. But upstream under the Konveyor community, some of those tools are only upstream, and some of them become downstream and become fully supported by Red Hat. But regardless, like all those tools are, again, about helping either modernize your apps in the different ways or migrate them on top of Kubernetes. And the main tool that we're going to talk about is Crane, which is about migrating Kubernetes application from one Kubernetes cluster to another one. But if we look at like the strategy, typically of modernizing your applications, like you might have heard of the 6R approach. So the first step is to understand, like for each individual application, like should you retain, retire, repurchase, refactor, replatform, or rehost. So a lot of those tools are related to that strategy. So if you look at Crane and Forklift, they're about rehosting your apps on top of Kubernetes. Move to Kube is about replatforming, and then Pathfinder and Windup are tools to help you refactor. But at the end of the day, each application or legacy application that you need to modernize would typically fit in one of those strategies, which can be then helped by those tools to port them or to move them into a Kubernetes platform. So let's talk about Crane. So Crane was originally built to help, from a Red Hat perspective, to help customers migrate from OpenShift 3 to OpenShift 4, which was about migrating your applications, right, like Kubernetes applications, from one cluster to another. That said, this tool now can be used for not only to upgrade from OpenShift 3 to 4, but to move from even from an existing OpenShift 4 platform to another one. And also, this tool has been designed to help you migrate at scale. So the concept is that you can take one application or multiple applications and then migrate them at scale from one cluster to another cluster. And we support all the way back to older releases. So on the OpenShift side will be OpenShift 3.7+. So any release after that is supported by the tool. The migration toolkit for containers, we just released the version 1.4, which is, so as I was pointing out before, all the work is done upstream under the Crane community. So what we have in Crane is always the latest and greatest. This is where we do all the work, and we keep improving the tool there. But a few times a year, then we do a full testing on the tool, and then we release a downstream version, which become the migration toolkit for containers, or MTC. So we just released 1.4, so this means that a few weeks ago, we finalized all our testing, and we then released the downstream version, which include a lot of new features and capabilities and bug fixes. But the main two features were a better way to migrate PVs, which we call direct migration using rsync. So in the past, we were using another tool that was called restick to migrate PVs, which the data needed to be copied twice, as it needed to be back. So the strategy was more to back it up and then to restore it on the other side. So with direct migration, then you can bypass this backup and restore process and directly copy from one cluster to another cluster using rsync, which makes it much faster when you have large amount of data that needs to be migrated. So the process is you still have the Kubernetes resources that are getting backed up and restored. And this is fairly quick because they tend to be small. They're just YAML files. But the PVs or the stateful data then can be directly migrated from one cluster to another and bypassing the backup. And you'll see more when I talk about the architecture, how this works behind the scene. A second thing we have significantly improved in the tool is what we call the migration pipeline view, which allow you to have better visibility into what's happening during a migration process. So one feedback we got from customers is as they were migrating a large amount of applications, sometimes it was hard to understand exactly like what was happening behind the scene of that migration. So, and as everything is UI driven, we try to make it as easy as possible from a UI to migrate your apps. Then now the UI has a better view into exactly what's happening and can report like a pipeline view of what's happening during the migration process in the tool. We also have upstream a best practices guide to help people think about migrating at scale. In this case here is from OpenShift 3 to 4, but I would say those steps would actually apply to any large migration from one cluster to another. And so by doing this a lot with multiple customers, we kind of learn like what are the best thing to do to be successful at migrating applications between Kubernetes clusters. And it all comes down to the same 5 steps, which is planning. So understanding what is your strategy from the migration, because outside of just migrating the Kubernetes objects and the PVs, then you need to think about are you going to change your DNS configuration or your load balancer configuration, or what you have from a throughput point of view, like how long migration will take, and so on. So there's a lot of things to consider and plan for when you're migrating at scale. As well as we found that sometimes the clusters are not in good health, so before migrating at scale, it's really important to do some checks to make sure that everything is actually good on both sides, on the source side and on the destination side. So we're trying to provide some instruction on how to do that. How the tool works, understanding some testing that should happen before you migrate, and then after that, it's all about running the migration and troubleshooting when you run into trouble. So obviously we have the official documentation, which is either available under the Konveyor project or under the OpenShift documentation in the migration section. But those documentation are more about how the tool works and how to install it and how to use it, where the best practices guide is more about how to plan and how to have a strategy to migrate at scale from one cluster to another. So when we talk about MTC, we have different ways of migrating the persistent volumes of the PV, which is one of the key phases during the migration, as this can be a lot of data that you need to migrate from one cluster to another. And the most common, or like today in the current version of the tool, the recommended approach would be to use the direct migration or the rsync new feature that we just released, which should be, in most cases, the fastest way to copy data from one cluster to another. That said, there's also other strategies or other ways that are available in the tool for some specific use cases that might be better than the generic one. So we also have another feature, another capability is called Move. So Move today requires NFS storage and requires that storage to be both available on your source side and your destination side. So when you have the same NFS storage attached to source and destination, then we can actually, during the migration process, instead of copying the data, we can unattach the PV on the source side and reattach the PV on the destination side, which makes it much faster. If you're in the cloud, if you're running on Google, AWS, or Azure, then you can also leverage cloud snapshot capabilities, which also can be a very efficient and fast way to copy the data, but you have the requirement of using those cloud storage. And finally, we have the legacy option, which is RESTIC, which is the backup and restore process. The reason why this is still there in the tool, even if we have now the new direct migration option, is because direct migration has a requirement to have network connectivity from source to destination. So if you have network connectivity, the direct migration rsync process is better and faster. But if you don't, then RESTIC stays the best option, as you would be able to migrate your applications without having direct network connectivity between both clusters. If we look at the architecture of how this works, so you see here I have my source cluster on the left side, my destination cluster on the right side. First of all, I need some object storage repository that is going to be used to copy my Kubernetes object. So the way the tool works, obviously we have, as I was saying before, we have rsync to copy the PVs, which is done actually over stunnel from source to destination and bypass the object storage repository in the middle. But what is actually underneath the tool taking care of the backup and restore of the app is another open source project that is called Velero. Velero is a well-known backup and restore tool for Kubernetes object, but this tool requires some object storage in the middle to copy the data to and from during the migration process. So you need some object storage, but which can be easily done. It's mostly the API that you need and can be backed by any PV. So even if you don't have an object storage, today, you could easily install one on your Kubernetes or OpenShift cluster and just back this up by any storage or any PV of your choice. And then the migration tool or MTC or Crane would get installed on the destination side. And this is where you would have the controller and the UI to actually make the migration happen. So what the controller, actually everything is API driven. So all the work is done by the controller. And the UI is just actually doing the API call for you on the controller side. And then the controller would talk to the Velero on each side or would launch the rsync process to copy the data, but orchestrate the full migration from end to end. So, and then behind the scene is actually Velero that does the backup of the Kubernetes object and the restore on the other side. And all that can be driven, as I was saying, from the UI, which is typically installed on the destination side, but could be installed anywhere as it's all API driven. If we look at the move method, so it's exactly the same thing, right? So Velero would still take care of my Kubernetes object to back up and restore them. But in this case, for the PV, like the controller will unattach the PV on the source side and reattach the PV on your destination side. So if this is available and you have NFS storage attached to both sides, then this becomes a faster way to copy the large amount of data you might have between source and destination. And if you're in the cloud, then you can use snapshot capabilities of the cloud to actually migrate. So in this case, it's just the snapshot ID that would be copied into your object storage, and then restore on the other side to get the data available on the destination side. And if none of that work and you don't have network connectivity to use the rsync method, then you can still use the rsync legacy option that was available in the tool before to do a full backup in your object storage repository, including all the PVs, and then we'll restore everything on the destination side. When you're migrating, you have an option to do a stage process before clicking the final migrate button. So what a stage allows you to do is to copy as much of the data as possible before the final migration. So typically what we would see as an example is running the stage process during business hours. So the vast majority of the data has been pre-copied. And then during your maintenance window at night over a weekend, then you click the migrate button, and then we would only copy the difference between the last time you click a stage. So this way, we can accelerate the migration by not having to copy everything before quiescing the application and then finalizing the migration. And the stage process can be done multiple times, so it can be done as many times as you want before you finally click the migrate button to finalize the migration process. And we'll look at the demo in a couple of minutes that shows all that. But here, actually, this is my slide for the demo. So everything we've been showing here, just give me 1 second. I'm going to share my other screen, which is the demo. Sorry about that. Yeah, so here it is. If I can put this full screen. Hopefully this looks okay on your side. I'm going to click play here. So in the tool, first thing is to configure the clusters, the source and destination cluster. Here, they're already pre-configured for me. But you would have to configure your credentials to connect to the source side and the destination side. Read that a little bit. Then you would have the object storage repository that needs also same thing. You just need to configure the credentials, and then you're ready to create your first migration plan. Then I would give this plan a name. So in this case, I'm going to call it demo. I'll pick my source cluster and my destination cluster. And the migration plan is just like a list of namespaces that you're looking at migrating into the same maintenance window. So here I have all the namespaces that are available to me on my source cluster to get migrated on the destination side. So I'm just going to pick up one. And I can see the list of the number of pods and PVs and services that will get migrated during this process. And now the tool is discovering all the persistent volume that I have in this namespace. And I will pick the right method that I want to use to copy those PVs, right? So we talked about like direct migration versus snapshots versus, so in this case here, do I want to do a copy or a move first? That's the first question. So in this case, for each individual PV, I'm going to select copy. But I could use move if I have NFS storage attached to both sides. Then I'm going to click next. And then I have a choice to do a file system copy or a snapshot copy. So if I'm in the cloud, then I could leverage the snapshot capabilities to copy my data instead of doing a full file system copy. And also I have a verify checkbox there that if I would need to do a checksum at the end to validate, I could do that. It would take a little bit more time for the copy to be completed, but this would do a checksum to confirm that nothing has changed on the data side during the migration process. And in this case here, by default now in 1.4, we would use direct migration, which as long as I have direct network connectivity between both clusters, this should be available in the available state. Same thing for images. So all the registry images that are attached to this namespace as well, as long as I have that direct network connectivity and my registry is exposed to a route, then I can directly copy from one cluster to another all my PVs and my images from my registry. I'll accelerate that a little bit. And here I have another concept which is called a hook. Hook is a way to add some automation or to run some script at some point during the migration process. So if I want to automate something else like changing my DNS record or updating my load balancer configuration or anything else, I can create a hook, which can be either an Ansible playbook that I could copy paste here, which is what I'm going to do here, or it could be any container image. So if I want to run any kind of script, I could just like build my script into a container image, and we'll run this container at some point during the migration process. So here I can select if I want to run this on my source cluster or my target cluster, or if I want to select a playbook or custom container image. In this case here, I have the playbook. I'm going to run this on my target cluster. And then I will have to select the service account name that I want to run that into, and the namespace as well, where the script is going to run during the migration process, and as well as the phase, right? So I'll have access to run this playbook either pre-backup, post-backup, pre-restore, post-restore. So here in this case, I'm going to run this at the end. And this is just a way, again, to be creative and to add any other need that you might have from an automation point of view. And then I have my plan that is fully ready. I can look into what is going to get migrated to the list of namespaces, the amount of disk space that is going to have to be copied. In this case, I have one PV of 40 gig, and then I'm going to click either the stage or the migrate button. So in this case, as this is a demo, we'll skip the stage. We're going to go with migrate right away, but I could stage this during business hour, as I was saying, and then just do the migrate part at the end in my maintenance window. So we'll click the migrate button here. Here I have an option to actually, if I want to test that, like in this case, by default, like we'll halt the application on the source side and launch it on the destination side. Let's say that I want to migrate my app, but I don't want to stop it from running on the source side, like in this demo here. I could just uncheck that, and this would allow me to test that actually I can migrate my app and it's running well on the destination side without affecting the application on the source side, as I will not shut it down at the end. So this is a way, as an example, to do a test and to validate that my app could be running on the destination side without affecting the source side. So now my migration has been started. And this is the pipeline view. That is the new capability we added in 1.4, which is going to give me details of exactly what's happening behind the scene during the migration process. So you see all those steps here that actually are going through during each migration. Obviously, this is an accelerator. This has been fast forwarded, so we don't have to wait for the copy of 40 gigs. But in a nutshell, like we're copying all the data, we're copying the images, all the volumes, and then the application is launched on the destination side. So that was it. And then after that, here you have an option to actually, if something went wrong, you could roll back the migration process, or you could actually go to a debug view, which would give you ways to look at the Kubernetes objects behind the scene and all the logs for troubleshooting purposes if anything went wrong during the migration. Come back to that. Here. So that was it for the demo. I don't know if there's any, actually, Jonathan, maybe you can tell, is there questions? Or you can join, obviously, those meetups. Please go to the Konveyor website. It's on konveyor.io. If there's any questions.
Yeah, thanks, Marco. So right now we don't have any questions, but we'll give everyone a second. Maybe they need that to type it in. And if you guys have any comments, feel free to share them.
And you can get access to this tool on the konveyor.io, as I was saying. If you click the forum, then you can join our forum to see what's going on, all the migration tools that are getting built onto the Konveyor community project.
Yeah, so I don't see any questions, Marco. So I think you did a really great job and explained everything. I went
fast today. Sorry, maybe I had too much coffee this morning, so hopefully that.
All right, everyone. Well, if you do have questions, we'll be sending out the recording slides. I'll be coordinating with Jay on that. So, and if you have any questions, just feel free to respond to that email, and we'll get the right person to answer that for you. But with that said, thank you again for, yes, because he just put a question in there. I will be sharing the slides as well. So yeah,
Thanks, Jonathan. I'm Jaya here. Hi, Marco. Thank you so much for today's session. Marco, there's one question I have, which I hear from our partners frequently, is about best practices. Do we have any gotchas or any challenges, any typical challenges that we face? For example, using our PVs or while you're migrating from one cluster to another, downtimes, or are there any such challenges that we typically could potentially face based on our experience that you could share?
Yeah, and that's why we have created the best practices guide that is available. Actually, pretty much like the things that we've seen are the most common issues. That's what we're trying to document there on our best practices guide upstream. So that's part of. If you get access to the slides, you'll have a link to that. Maybe I don't know if there's another way to share the link.
The COP link is that Red Hat COP? Got it.
Yeah. So what we're trying to describe in there is the most common issues we've been seeing, and the way to prevent them, right? So the customers that are the most successful at migrating applications at scale, the one following those steps. So from, as I was describing, like from planning. Obviously, understanding, like, first of all, like, what is your process to migrate at scale your applications? Are you going to deal with DNS, load balancing, to reduce downtime as well? Obviously, there's some downtime involved during the migration process. You can reduce that by using the stage capability and then the final migration, which significantly reduce the amount of downtime, but there's still some downtime involved. So it's important to understand that, as well as making sure your clusters are in good health before starting a migration. We've seen issues where some clusters are so saturated or oversubscribed, and it becomes difficult to copy large amount of data, obviously, as there's not enough storage I/O or network throughput to be able to copy. So doing some pre-migration testing, understanding if you have the throughput and the I/O available to you to migrate at scale. All those things are described into our best practices guide, as well as obviously, like, we're trying our best for this tool to be as resilient as possible, but there's all kinds of applications and all kinds of issues that can happen during migration. So that's why we have created a troubleshooting section. And having some knowledge on how to troubleshoot when something goes wrong during a migration is actually probably another key element to be successful with migration.
Awesome. Thank you so much, Marco. Really appreciate your session today. And thanks, Jonathan, for helping to schedule this as well. Over to Jonathan.
Yeah, of course. All right, everyone. Well, hope you enjoy the rest of your evening, and we'll be sending out the recording slides to you soon. Cheers.
Thank you. Thanks, Jonathan. Take care. Bye.
Thank you.